Hi, I'm Rob Hawker from Meloro Analytics, and I'm here to talk to you today about data profiling in Microsoft Fabric. So have you ever been given a data set which you know nothing about? You don't know if it's got null values in some columns, you don't know if it's got duplicates, somebody's asked you to do some data engineering work with it, somebody's asked you to do some visualization. You have no idea whether you're going to be able to do that or not because you know nothing about the data. Well, this is where I hope this video will help. So Microsoft Fabric is going to be a place where a lot of us put much of our data in lakehouses, warehouses, and so on and so forth in the future. And we can use data profiling tools within Microsoft Fabric with minimal cost, just a small amount of capacity consumption. I'm going to show you in this video how to go and do that. So let's get started. Okay, so the first step in this video is going to be uploading data into Fabric. So there are many of you, I'm sure, who know how to do this really well and have used other great content that's out there already to learn how to do it. But some people will be coming to this video from the data quality world, and I wanted those people to have one single resource to be able to go end to end, bringing data in and then profiling that data. So those of you that know this stuff already, just skip through and find where I start talking about notebooks. But for the purposes of making this an end-to-end resource, I'm going to start by creating workspaces and lake houses and loading data into those lake houses. So let's get started. I'm going into workspaces, clicking new workspace, and I'm going to call it data profiling video. I'm going to copy that because I'm going to use that name again. Click apply, and we have a new blank Fabric workspace. I'm going to click now into new and lakehouse. I'll use the same name for the lakehouse. So this is an empty storage location effectively for data. So we've got a tables section and a files section, and we're actually going to put things in both of those. We're going to load a single file from my computer into this files directory, and we're going to load some tables from an Azure database into the tables side of things using a data flow. So let's get started. So we're going to click on upload files, and a simple dialog appears for us where we can just click on this folder here, and we can go straight to the relevant directory, and we've got vehicle data, and it's just 629,000 kilobytes, so it's quite a large file. It contains many vehicles it contains a list of all vehicles involved in traffic accidents in the UK over various years, and it comes from a Kaggle data set. So we're just going to load that into our files section. So we're just going to click upload, and this will take some time to complete, but it will carry on in the background. So what we'll do now is we'll actually leave this screen, and we'll start creating our new data flow. So simultaneously as it's loading the file, we'll also be going off and getting some data from our SQL database and bringing it into tables. I've clicked new data flow generation 2. It's just going to take a second to start doing that and open up the Power Query user interface. So here's our Power Query user interface, familiar hopefully to some of those of you who use Power BI desktop. So we have our transform and add columns section, which hopefully many of you have seen before. We're going to import data from a SQL server. So I'm just going to type in the details of the server. And the database. And because I've used this database before, there's already a connection set up, so ready to go. I'm going to click next, and what will happen now is it will open up the database and show all the tables which are available to be loaded to our lakehouse. So for the purpose of this, I'm just going to load two tables, Dimension City and Fact Sale, and click create, and this will then come into our Power Query user interface. Now, whilst working with this profiling tool, I'm going to show, I've noticed that it doesn't deal very well at the moment with date columns or links to other tables. So I'm just going to, for the purposes of making this a nice easy demo, I'm just going to remove those date columns and the links two other tables that you see here just by selecting all with the control key and then removing columns. And I'm going to do the same thing in the sales query as well. So we'll go to the very end and remove all these linked tables and go back and remove the date columns as well, which should mean that our profile works first time. So that's already complete. Now, because we selected create generation 2 data flow right from the Lakehouse dialog screen, it already knows that we want to write our data into a Lakehouse. If you just created a brand new data flow from scratch, you would actually have to choose the location that you want, and that's shown in the blog that accompanies this video. But you would just change these settings and work that way. So you can already see that these are not going to be loaded into the data flow themselves, because these are shown with italics basically, which means they're not going to be loaded into the data flow itself. It's going to be loaded directly into that Lakehouse. So last thing I'm going to do here is just rename the data flow to something more meaningful. So I'm going to call it data profiling data flow, and just click off that dialog and it renames. And now I'm going to click publish. Now two things are going to happen. So the data flow is going to be published, and then it will automatically refresh, which means it's going to pull data from the SQL database into our data lake and give us our lake house and give us the latest data. So you can see the publish activity is going on at the moment, and then in a few minutes, once it's finished publishing, the refresh activity will happen. And so that by the time I go back to the Lakehouse, we should expect hopefully to see the file that we uploaded in the Lakehouse, and then also the two tables from Azure SQL Server fully loaded into the Lakehouse. So here we are back looking at the workspace again. So we can see the data profiling data flow is now published, and when we look at the refresh history here, we'll be able to see that the refresh is completed as well. So here's the refresh history, and we can see it completed in 20 seconds, loading the data from those two tables into our Lakehouse. So let's go back into our Lakehouse now and take a look. So we have our two tables, Dimension City and Fact Sale, available to us, ready for our profiling. And we've also still been loading our files, and you can see we have our vehicle data CSV file in here as well. Now, before we actually start the process of profiling, we just need to do something called setting up an environment. And the reason we need to do that is because the data profiling tool that we're going to use is not native to Python. We need to tell Python that we're going to be using that, and that we're okay and accepting that we're going to be using that. So to do that, we come in here and we create new, and we go to more options, and this time we're going to click on environment. And so I'm going to call the environment the same thing that I have been calling everything else, but obviously you may want to come up with more meaningful names. And now it says there's nothing here, and now I need to add from a library in here. So I just need to type the name of the library. So I'm going to say data profiling, and you can see that this is correct because straight away the tool is able to identify that there's a version 4.8.3 out there, and if I wanted to, I could choose earlier versions. Obviously I'm going to stick to the latest version for this. Now once I've done that, I can just go ahead and click this publish button, and it will make that environment available. And this does take a few minutes usually to complete. So you can see the progress in notifications. So publish is in progress, so it'll take a little while to go ahead and complete for us. Whilst that's doing that, we can make a start with the work we're going to need to do in our code in profiling. So the next thing we're going to do actually is we can either create a new notebook from here, or we can actually go into our Lakehouse to create this new notebook. And I think I'm going to do it this way around. We're going to do it within the Lakehouse. So I'm going to say open notebook and new notebook. So what is a notebook? A notebook is a place where you can type some code to tell Fabric to do something, basically. And we've got various different coding languages available to us. I'm going to stick with Python because that's all we need really for this particular exercise. but you can use whichever one you want. I'm just deleting those couple of lines of commented code because we don't need them. And we already have our lakehouse in here. If you'd created your notebook directly from the workspace, you would need to allocate the notebook to this particular lakehouse by clicking add lakehouse in here, but we already have it, so that's good. So the first thing we're going to try and profile is our vehicle data CSV, and to do that we're just going to click on these three dots and we're going to say load data Spark. Now actually the data profiling program we're going to use actually wants the data to be in pandas format, but what I found when loading it directly into pandas and using this code that you get automatically when you do that, I found that the profiling tool didn't work properly. So I'm doing it the other way around. I'm going to say load data Spark, and just to keep things simple, I'm going to delete the code comments that you get because they don't actually do anything. They just tell you what's going on. I'm going to explain to you what's going on, so you don't need that. So the first thing that happens here is it says create a data frame. So a data frame is a very common thing in Python where you're basically loading data from a source into an Excel type frame, where you can see rows and columns of data. So df data frame equals, and it's saying read using Spark the CSV format with and it's got headers, and get it from files vehicle data CSV. Now if I just go ahead and run this, it will give us a data frame that looks very much like the file if we were to open it in Excel. So this is going to take a few seconds to get what's called a session, and once the session is here it should take a few more seconds just to run for us to show us the data in that vehicle data. Here we go. So we have our various columns of data visible for us now, so that's great. So our next task is going to be to convert this Spark data frame into a pandas data frame, and we need to do that because our data profiling software that we're going to use needs pandas. So first thing we'll do here is bring in the appropriate Python library. So we're going to say import pandas as PD, and PD, and we're going to say from our existing library that we've already got in our environment, we're going to say from data profiling import profile report. So that's for later on. That's what we're going to do in a second. That profile report is the tool that's actually going to produce our data profile. So the next thing I'm going to do is say to pandas and open and close parentheses, and that is going to give us a pandas data frame instead of a Spark one. So when I run this, it will look pretty much the same. Just waiting for this session to connect. Okay, so now that our session is connected, we should now be getting our notebook running. There we go. Our jobs are in progress. And there's our pandas data frame. Okay, so everything's working so far. So now actually we don't need to display the data, so we'll remove that. What we're looking to display is the profile. So I'm going to paste in a couple of lines of code in here. So the first one, profile, is just saying use that profile report function, take the data frame that we've given you, the pandas data frame, and give us a profile report with the title vehicle profile report. And then this is going to say display the profile here in our notebook. So when we run this, instead of getting the data, we're actually going to see our profile for the first time. Let's watch for our Spark jobs running, and you can see now that it's working. So it's summarizing the data set. So it's going to go through each column of that data set and produce a profile off the back of it. Okay, so the summarized data set step is complete. It's now generating the report structure and rendering our HTML, and we should see a result in just a second. Here we go. So we're now starting to see our data profile. So I can go through each column. So we're looking at the age band of drivers, for example, and it's going to tell us the number of distinct values that we've got, the number of rows of data that where there's no data, when things are missing. It gives you a broad spectrum of the different values that you have. We can click more details and see additional information as well. So lots of information available. So that's just one column of our data. We've now got age of vehicle as well, where we're starting to see things like the word clouds telling us what's going on. We'll come back to all of this later, but for now we can look at things like in the report we've got alerts. So it says there's a number of fields that have high correlation with one another. So this is an interesting one. Journey, purpose of driver is highly correlated with was vehicle left-hand drive. My guess is that in the UK it's not usually left-hand drive. Most vehicles are right-hand drive. So if something's left-hand drive, the purpose of the journey is probably leisure, probably vacation, because people have driven over from continental Europe to the UK. So it's not surprising at all that those two columns of data are highly correlated. And we also see other information in here as well. So there's imbalanced data where almost all the values are the same, and we see things like missing data where it's alerting us that there's missing data. So straight away the profile is giving us some quite useful information. I hope you agree. So that's great, but problem, we've only got the profile right now in this notebook, and whilst we can come in here anytime we want and run it and look at it, that's not really what we want. I think the best thing usually with a profile is to be able to share it easily with others. So what we then can do is remove the display profile step, and we're going to add 2 additional steps in here. So we're going to say we want to define a location, and so I'm just going to call this profile location, and we're going to say we want to then write a file to that location. So this is now saying here's a location in our lakehouse. So we're going to want to have lakehouse default files, completed profiles, vehicle data, and we are then using another part of the Y data profiling features just to say profile to a file in that location. So to do that, just one thing we're missing, we don't actually have a folder at the moment called completed profiles. So we're going to go back to our files, back to the files screen here, and we're going to say new subfolder. I'm going to write completed profiles and click create. And if you're wondering how I got this directory path, the easiest way to get it is just simply to go to that directory that you've created, click the 3 dots and say copy file path API, and then paste into here. You can see that gives me exactly the same string that we have up there. So that's how you get that information, and I've just then added the name that I want the HTML file to have when we run this. So that's it, that's all I need. I'm going to now click run, and it's going to do exactly the same thing again, create that profile, but this time we should see the profile in our files, completed file profiles folder. So let's wait and see when it completes. Now obviously we could finesse this code to some extent as well. We could do things like adding parameters to choose which file we want to run the profile for. We could have nice messages that tell us when things have completed successfully and so on and so forth. But for now I'm just showing you the basics, and you can do whatever you want around that. Okay, so again, the profile's complete. We're generating the report, and it's then going to go into our completed profiles structure. So we now have this additional step, export report to file, and then when I go into the completed files folder, we have to refresh, and there's our vehicle data HTML. Now we can then open our file explorer, and we can go down to OneLake, Microsoft Preview, and I can actually just sync this. So I can say OneLake, sync from OneLake, and there's our new workspace, data profiling video, and at the moment that is also empty, so I just need to quickly sync that one as well. There we go. So there's our lake house, there's the files section, completed profiles, and there's our vehicle data profile. Now when I open this profile, it's exactly what we saw before, but this time it's something I can open in the browser, I can share with others in my organization. So as you saw, I'm using the OneLake file viewer that you can get, file explorer that you can get for your machine. So if you haven't already got that, you can download it from Microsoft, and I will put the link in the description of this video. Okay, so going back to our notebook, we've now done everything that we wanted to do looking at this vehicle profile. What we're going to do now is actually do something very similar, but this time for the dimension city and the fact sales table. So we'll work in a different cell of the notebook. So I'm going to paste in the relevant code this time. So we're going to say exactly the same as we did before: import pandas, import Y data profiling profile report. And we're going to bring in our dimension city table and change it to pandas. We're going to profile it and we're going to save the file for that in the same location that we saved the other one in. So it's exactly the same. The only thing that's going to look slightly different here is I'm going to say load data Spark, and there you go, we get the correct row of code there. Let's just compare that to what we have in the pasted code. So it's exactly the same. It's just that this was from a different demo that I did, so it doesn't have the underscore video in the name of the lake house. So I'm just going to put underscore video in here to make that correct. And you notice the one that I just created has got limit 1000. So by default, what happens is when you use this here to load data into a data frame into Spark, it always limits to just the first 1000 rows for performance reasons, understandably. But we're going to need to avoid that for this because profiling does require the full record set. So obviously profiling over 1000 rows could be interesting, but it's much more likely to be interesting when you're looking at things like the extremes in your data if you go ahead and profile the entire data set. So that's actually all we need for this one. And we're now going to do the same thing. I'm going to add another cell down here, and I'm just going to change this table name to fact underscore sale, and then I'm going to change this to say sale data profile, and that's it. Both those cells should work. So I can now run both of those cells at the same time, and we will hopefully get 3 completed data profiles. So we can see the first one's almost finished. There we go, the export to file, and now we've got the sale data one completing as well. There's a lot more columns on this one, so it'll take a little bit longer. Okay, so this one's now almost there as well, rendering the HTML, exporting that to file. So there we go, we should now have 3 completed profiles in here. So let's go back to our OneLake Data Explorer and sync this directory, OneLake, sync from OneLake. And let's see, yes, we have 3 completed profiles. So there's our city profile, and here is our sale profile. Fantastic. So that's it for the actual process of profiling. We just have one step to go, which is to start to use and interpret those profiles and think about their relevance to data quality. Okay, so let's see what value we can generate from looking at the profile. So I'm looking now at the city data profile first of all. We also have the sale data profile and the vehicle profile, which I'll come back to in a minute. So starting with the city data, the summary here just tells us how many rows of data we've got, 116,000, how many columns. It tells us if we've got any missing data in any rows, the size of this table, how many columns are numeric, how many are text, how many are categorical, so on and so forth. And then what I would generally do with this is just go through column by column and see what I can learn. So the first column where I found something interesting, I would say, was the location column, which is meant to be latitudes and longitudes. We'll come to that in a minute, but you know, I look at a field like state province here and I don't learn very much. There are 54 distinct states. That sounds quite consistent with the number of states in the US. There's no rows with missing state, so we've got good complete data. You can see from the word cloud that the values look pretty good, so I'm not going to even bother clicking more details because I can see this looks pretty good. I've not got any major worries about that data at the moment. But then when I get down into the location, I immediately notice in this word cloud that we've got lots of latitudes and longitudes, which is great, but then we have this massive word point. And then I click on more details and I can actually see that under here we have the word point as the most frequently found value. So we've got 116,000 rows that has the word point in it. and that's a third of our data set here. So you need to, you definitely would want to look into why that might be the case and what's causing that. So perhaps that's just the way the data is formatted, and most rows have got the word point in somewhere, but definitely something that I would query, because if I was trying to use this as purely longitude or latitude data, I would have problems with it because the word point would interfere with that. So that's an example of what I might get from my profile for city. If I go on to the sales profile quickly as well, again, flicking through, the first thing that I noticed was we have this customer key here. So this is the number that our sales are allocated to customers and products and things like that. So we're saying we've got 200,000 rows or so, 228,000 rows of sales, and those are made to a total of 403 customers, which may or may not sound feasible. If you know your business, you would know if that's a feasible number of customers or not. But what I noticed straight away is the minimum value here in the profile is 0. And customer keys should start with at least a 1 as a minimum value. So if it's a 0, it means it actually hasn't been allocated to a customer. So we've got many sales that have been allocated to this value of 0, which means there's no link between the customer and the sale, which obviously is not ideal for our analysis. So you can see that from this histogram on the right hand side as well. So immediately we have something really important to go and sort out here in our sales data. Then finally, going to the vehicle profile report, we've got 2.1 million rows of data in here. So this is looking at accident data, looking at cars involved in accidents, lorries, trucks, etc., and the locations of the accidents, types of vehicle, things like that. And again, straight away you can just sense check the data by looking at the profile. So this age band looks pretty sensible. The age of vehicle looks pretty sensible, although we notice we've got not applicable in here. You would have to sort of question why it's not applicable in so many cases. Again, we've got NA in here for 16%. You might understand that sometimes they can't work out the age of the vehicle, but surely not 16% of the time. So maybe our people collecting this data could do a little better. We also have lots of values. If you go across all these columns, you've got lots of values where it says data missing. So we actually have a missing statistic of 0, but the data itself allows people to put in a value of data missing, and you see that quite often. NAs in that one, and if I keep going, we'll see this one's particularly bad. Journey purpose of driver, we've got not known and then other not known, which really just means the same thing, doesn't it? So again, it looks like no data is missing, but actually we've got something like 1.4 million records here that are missing that information. And again, presumably in the situation where there's been an accident, it should be possible to get a proper category for the journey purpose of driver. So I would just like to show one more thing on this profile that I think is really interesting, and that's the correlations between the different fields. And I did point this out earlier in the call, but just to finish this off, we've got was the vehicle left-hand drive, and you can see there's strong correlation between these other two fields. They're slightly cut off, but what they actually are these ones here. So journey purpose of driver and junction location. And I think that's really interesting, because I can see then straight away, if the vehicle's left-hand drive, just to be clear, in the UK, vehicles are generally right-hand drive. If you're driving a left-hand vehicle in the UK, that vehicle probably originated somewhere on mainland Europe, France, Germany, so on and so forth. So if somebody is over here driving their left-hand drive vehicle, they've probably come across the Channel Tunnel, brought their own car to the UK when they're used to driving on the right. So the correlation then does make some sense, because the purpose of the driver is probably always going to be recreation, some kind of recreation, holiday, vacation, etc. for left-hand drive, or potentially if it's truck drivers, they're over here working, but there's going to be some commonality between those values, which is interesting. And perhaps we should be writing data quality rules to pick up when the values are not common for some reason. And then the other one, junction location, I had to do a bit more thinking about that one. But my hypothesis, which I'd like to test then by talking to a business person and looking at the data with them, my guess would be that somebody coming over here and in the UK with a left-hand drive vehicle, probably one of the hardest junction types for them to run into is a roundabout. We have a lot of roundabouts or road circles here in the UK, and when you're used to driving on a different side of the road, those road circles can be really challenging. So my guess is that there are a lot of accidents at roundabouts in the UK caused when people are not used to driving in their left-hand drive vehicle on the left-hand side of the road. So again, I think that interesting to see that correlation. It does really get you thinking about the data, and it can really help these types of conversations happen with your business people. So with that, I will leave it there. Very straightforward to get this information, and once you've done it once, you'll be able to do it again and again for any new table of data that you run into. And I think it really does add a lot of value to the discussions and analysis of data. So thanks for listening, and best of luck. Happy profiling.